Hello viewers, welcome back to the ZQTech YouTube channel. In this video, I'm going to discuss about some important questions and their answers a naval architect should know. And these are very important questions. So let's start with the Archimedes principle on which the floating and the displacement of the ship works. So I hope that you all of the naval architects knows this principle and have a good concept of this principle. But there is a question arise from this concept, and that is related to the density of the ship. So there are basically three densities I would like to tell you. First is like the density of the water, and second is the density of the ship. Third is the density of the steel plates of which the ship is made. If you compare all these three densities, then you will come to know that the highest density is of steel plates. Then it comes the density of the, after this, on the second number is the density of the water, and on the third number, the density of the ship comes out. So now you are a little bit confused that how is possible that the density of the ship is very less and the density of the steel plates is very high. So I would like to tell you is that the density of the steel plates is 7.8 tons per meter cube. So it's the density of a single square steel plate. So if you talk about the density of the water, it is 1 ton per meter cube. It is the density of the water. But if I talk about the ship, the density of the ship is ranges from zero point 0.2 to 0.35 tons per meter cube. How is it possible that it has less density? There is less density of a ship. Ship is not a dense structure, it's a hollow structure. It is made up of plates. So that's why its density with respect to the water is less. Ship is a hollow structure. Uh, and it's not a dense structure. If you fill the ship with all the steel and then you place the ship in the water, then it will certainly and obviously sink into the water, because at that time the density of the ship becomes equal to the density of the steel plates. So that's why um, ship is made up of steel plates. So ship is hollow from inside. So that's why its density is less than that of the water. That's why ship floats on the surface of the water. That is the first question of which I have answered you. Now move forward to the second question, and that is the forward perpendicular and aft perpendicular. So forward perpendicular is simply the point in the forward portion where the water line touches, and if you draw a perpendicular line from there, that is the forward perpendicular. That is easy. But aft perpendicular is a fixed point, and if you draw a perpendicular line from the shaft of the rudder or the rudder stalk, then that perpendicular line is considered as aft perpendicular in case of every ship, almost in every ship. And you will not say that the in the aft portion and the point where the waterline touches the hull and you will draw perpendicular line, that will be the aft perpendicular. No, that is not. The aft perpendicular is defined as the vertical line drawn from the shaft or the rudder stalk, and that would be the aft perpendicular of the ship. Now, move forward towards the third question, and that is the neutral equilibrium of the ship. So, anyone can ask you from you that what happened to the ship when the ship is in neutral equilibrium. So, first of all, you have to tell him that at in the neutral condition stage, it is a transition state between the stable and unstable equilibrium. So, uh, at the time of neutral equilibrium, the center of the gravity and the meta center coincides at a point. And what is the condition of the ship at in this situation? So in this situation, ship is listed on either port side or its starboard side at a very large angle of list. So if you slightly pull the ship towards the water, then ship will certainly sink into the water. And if you pull back the ship out of the water, then ship will come out of the water, it will not sink. So uh, basically it's such a situation in which the ship is at the verge of sinking into the water, and that and its concept is easily cleared from the GZ curve. GZ curve is a very important curve in this case, and it is it is good curve for determining the stability of the ship. specifically the static stability of the ship. So GZ curves indicates there is a range of heel angle for a ship. So if you look at the GZ curve from a net, then you will understand that on the x-axis there is a heel angle ranges from 0 degree to 80 degree, and on the y-axis there is the GZ value, the writing lever value. So if you focus on the x-axis value, so for a ship, so it the graph is most of the ship ending around on the 70 degree heel, 80 degree heel. So the point where the graph is ending is the point where G, the center of gravity, and the meta center coincides. And if you go below this graph, then the ship will sink into the water, and further beyond this heel angle you will see that ship will sink into the water. I hope that you understand these terms I have told you, and hope that uh, I will tell you about some other important questions and their answers in the coming video. So watch this video, and also share this video with your friends. Thanks a lot, and thanks for watching.